Hello students. Next we are going to look into what are the systems and the classification of these systems. System is an entity or a functional block which accepts an input signal which is x of t and then transforms it into a different signal and gives it as an output y of t. Please note here that the input signal is always referred to as x of t and the output signal is always referred to as y of t. X of t is the mathematical equation of the input signal, and similarly y of t is the mathematical equation of the output signal. In that case, the system is also referred to as a mathematical equation, and the mathematical equation of the system is called as the impulse response, and it is written as h of t. It is written as h of t. How the equation is being represented is basically by two different methods. One is either we write the equation of h of t, or we define the system by h of t, which is also called as the impulse response. Or another way is we directly write what is the equation of y of t with respect to x of t. That is the equation that is written here. That means y of t is some transformation t of x of t. If it's for a discrete time signal, then we have the input signal as x of n, the output signal as y of n, and the equation that is written is y of n is some transformation of x of n, and the system impulse response is written as h of n. Now these systems, whether it be continuous time system or discrete time system, can be classified into various types. Let us look at some of the classifications. First is a static system or a dynamic system. So you can have systems which are called as static or memoryless, and the second kind of system is basically called as a dynamic system or a system with no memory. Second type of classification is a causal system and a non-causal system. Generally, I will define each of these terms in detail next, but generally a causal system is a practical kind of system that can be made, whereas a non-causal system is not a very practical system. That means a mathematical equation can be written about it, but it cannot be realized as a practical system. For example, you can write an equation of a time machine, but we cannot make a time machine, or we have not yet made a time machine. So a time machine is kind of a non-causal system, wherein you give an input and the output you get based on some input that you are going to put in future. But anyway, don't go too much into that. We will define that as we go forward. Next is a linear and a non-linear system. Generally, most of the system that we are having is a linear system. Non-linear systems are basically complex kind of systems which give outputs which are very useful. But most of the systems that we deal with are linear in nature. Most of the systems that we see in nature are mostly non-linear systems, and that is why in future people are trying to design more and more non-linear systems. Then classification of system into time invariant and time variant system. That means a system in which the output keeps on changing with time is basically a time variant system, and when it does not change with time, it is called as a time invariant system. The best example is, suppose we are talking about your Wi-Fi network. At some time you are going to get an output. Sometimes the output may not be very good. Its output will keep on changing. So since the output keeps on changing, that means the range keeps on changing, the output signal's power keeps on changing, you can call a Wi-Fi system as a time varying system. But any system which gives constant output is basically a time invariant system. A stable and an unstable system is another classification. Stable systems are those systems which, when designed, it is taken care that they always operate stable if a stable input is given to them. And an unstable system are those systems in which, even though the input is going to be stable, sometimes the output may go out of hand or it may go unstable. One of the classic examples of an unstable system is the nuclear reactor disasters that we see in very early days. For example, for the case of Chernobyl, when the nuclear disaster took place, finally it came down and people found out that the system itself was having an unstable nature, wherein a kind of input would slowly trigger an unstable output, and that is what happened there. So generally, whenever we design a system, we also try to take care that the system is always operating stable and it does not become unstable. There is a whole course that is dedicated towards this, which is called as control system, and that you will study in your higher semesters. So stable and unstable system. Then we have invertible and non-invertible system. Invertible systems are those systems which are, in which if you give the input and the output, you can change the input and output and you will get the results. Anyway, when we go in detail, we will define each of these classifications one by one. So let us start with the first one. Static and dynamic system. A static system is a system whose output depends on the present input only, and it does not depend on any past input values. So whatever is the present input, that is going to be the output, or that is only going to decide what is going to be the output. Whereas in a dynamic system, as it is written here, in the dynamic system, the output depends on present input, past input, and maybe even future input. An example of this static system is basically shown here, where you can see that the present time is t, and you can see that y of t, that means the present output y of t, depends only on y of x of t. It does not depend on any of the other values. Same is the case here in the case of discrete time also. Whereas when you come for a dynamic system, you can see that y of t depends on x of t minus 1. That means it depends on the input that was applied 1 second previously. So x of t minus 1. Or look at the case here. Y of t is x of t, that is present input, okay. But the second part of the equation is x of t plus 2. That means it depends on the output, present output depends on what is going to be the input after 2 seconds. You might be thinking that, is there a system like that? Don't worry, if we have written an equation, based on equation we can define the system, and based on that we can say that the present output depends on present input as well as a future input. So it cannot be called as a static system, it's a dynamic system. Same is the case here. For the case of discrete time, it does not depend on just the present input, it depends on the previous or past and future inputs. Since a static system does not require the storage of any of the previous input, that's why a static system is also called as a memoryless system. So a static system is also called as a memoryless system, and a dynamic system is called as a system with memory. Now let us solve some of the examples based on this. Find whether the following systems are dynamic or not, that means whether they are static or dynamic. So here, how do we write this? So here you can see very clearly that the present output is dependent only on the previous input, that is x of t minus 3. So I will write, since present output depends only on previous input, this is a dynamic system. Next, look at the second problem. Y of t is d square by dt square of x of t. That means it is doing a double differentiation of x of t plus 2 times x of t. Now when generally people have a look at this, they always feel that, okay, since it is x of t both sides, that means it is depending only on the present value of the signal. But we all know very clearly that if you are having any signal, this might be a present signal, but if you are going to differentiate it, a differentiation always happens. If you remember, it is basically del x of t divided by del t, where del t is basically tending towards 0. But if you take this definition, it is talking about the change in x of t with respect to time. Change in x of t means there is some value and there is some previous value, and the change between that is basically what is delta x of t. So whenever we have differentiation, it means that we are always going to go for a system in which there will be some storage mechanism to just store the previous value. That is why a differentiation system will always be a dynamic system. So I will write here, since the present output depends on differentiated value of present input, this system is a dynamic system. Let us look at another problem. Y of n is equal to x square of n. You can very clearly see here that the present output depends only on the present input. Therefore, I will write, since the present output depends only on present input, this is a static system. Let us look at the next problem. Here also we are y of n is dependent on x of n, but it also depends on x of n minus 2. That means some previous value. So we will write, since the present output depends on present as well as past input, this is a dynamic system. Let us look into the second classification, causal and non-causal system. A causal system is a real system whose output is dependent on present and previous input values. That means only present and previous, or I can say present or previous. A causal system is a physically realizable system. That means practically you can design a causal system. The examples you can see here, all of them are basically either dependent on the present values or they are dependent on the previous values, or both of them together. Same is the case here. Then what is a non-causal system? Non-causal system, also called as an anticipative system. That means, why is it called anticipative? Because it depends on future inputs. That means the present output, it will depend on future input. Now you can imagine, how can that system be? How can a system be in which, for example, if you look here, y of t is having a value which is dependent on present input, that is okay. But what is going to come in the next time period, how can you judge that, or how can you find out what is the input that is going to come in the next time period? So it's an anticipative system. That means you cannot decide, or you cannot find out a value or the input that is going to be exactly coming at the next instant of time. So an output based on that is basically a non-causal system. that is a non-causal system. So any system which has an input value which depends on future values of input, that is basically a non-causal system. It is also called as an anticipative system. Now when I am saying this, see, if any system or if any equation does a prediction, that is different. Don't think that a prediction system is a non-causal system. No, prediction is an estimation of what will be the output, not the exact value. Okay, so a prediction software, you should not consider it as a non-causal, it is a causal system anyway. So now you understand the difference between causal and non-causal. Let us do some problems. Check if the following systems are causal or not. So here you are having y of t, it is dependent on x of tau d tau. Now just try to have a look here. Suppose the integration, if I am going to find out, it is basically trying to, if suppose integration of x of tau comes out to be some p of tau, where I have to put the limits as minus infinity to 3t. Now suppose I am talking of a time period, let's say I want to find out what is y of 1. So what is y of 1? It is going to be p of tau minus, sorry, not p of tau, p of 3t. T is 1, so p of 3 minus p of minus infinity. So the present output depends not on x of 1, but it depends on x of 3. X got integrated to p, which already has this x value. So now you are having p of 3. Now p of 3 is something that is a future value. So how do I write this? How do I write this? I can write it like this. Since for values of time period greater than 0, y of t depends on future values of x of tau, the system is non-causal. It is not causal. See, if in this one the integration would have been from minus infinity to t, then it would not have been a big problem if the value is again x of tau, because t is something which will give you the present value. So it will depend only on present values as well as previous values. That is the integration. But when you write 3t means you are talking about the future. Let us look at the next problem. Y of t is equal to xt by 2. Here also you can see, if suppose I am having to find out what is the value of y of t is equal to 1, then I will get x of 1 by 2, correct? That is okay, because 1 comes after 1 by 2, so it is okay. You can say that y1 is basically dependent on the previous value. But if I put a minus value, that means if I want to find out what is the value of y of minus 1, then what do you find? Y of minus 1 is equal to x of minus 1 by 2. Now if you look in the timeline, if suppose this is 0, in this case 1 was here, okay, 1 was here and half was here. This is half. So you can say that the present value basically depends on what happened previously. Whereas if you are going to talk about this one, the output at minus 1, it depends on what is going to come at minus half, isn't it? Isn't it? So what can we say? We can say that for all the values where t is negative, that means for t less than 0, the y of t will basically depend on future values. So we can say that this is a non-causal system. So how will we write that? Since for t less than 0, the present output depends on future input, the system is non-causal system. Same is the case with the next problem. Y of n is equal to x of minus n. If I look into the time axis, this is 0, this is positive axis, and this is negative axis. We know that time moves in this direction. That means it goes from -2 to -1 to 0 to 1 to 2. So now what is the value here? If suppose I am going to take the output at n is equal to 2. So if I put at n is equal to 2, I will get y of 2, and the value of y of 2 is x of -2. That means what happened at x of -2, which is actually at this time. So you can see that the time is moving like this. If you are trying to take an output here, its value depends on the value at x of -2. That means it is some previous value. So it's okay. But what if you want to take for the case of y of -2? If you are going to take y of -2, you will find out that it is x of -2, which is x of +2. In that case, when you are trying to find out what is the output here, its output depends on the value that is at x of +2. That means its value depends at some future value of x. So again, the system is non-causal. So again, just like I wrote in the above case, I will write the same statement here. It will be, since for t less than 0, that means the negative values of t, the present output depends on future input, the system is again non-causal. Let us look at this case. In this case, you can see that y of n basically depends on sine x of n. We know that the sine value basically goes between, the value of sine basically goes between +1 to -1. Whatever be the value of inside, that means if I am going to say sine theta, whatever be the value of theta, the value of sine will always be between plus and -1, isn't it? So here y of n is basically straightforward dependent on x of n. So here this is a very clear case of being a causal system. This is something that can be very easily made. So we can write here, since the present output depends only on present input, the system is a causal system. So with these two classifications, we will end this first part of system classification. We will continue in the next video. Thank you.